Hello and welcome to today's video. This is the AMC 325 motor controller out of the 1995 Solectria E10, and it has issues. This is the one that was very jerky. I did some Swaptronics out there, and I tracked it down to this motor controller definitely has problems. So I'm going to demonstrate the problems here. We're going to do some troubleshooting on it, and hopefully we can get her back up and running. I believe this is the only thing that's left to repair on the vehicle other than the side view mirrors, and the side view mirrors did come in the mail. So I've got those. So I think once we get this up and running, we'll be in good shape. So without further ado, we're going to head and turn it on here. And it's complaining that the battery is full because I'm using the, can you see that light is on? We'll let it drain down for a little bit there. It's complaining because we're on the depth capacitor that's made previous video appearances. I'm bridge rectifying 120 volts AC to about 170-ish volts DC, and that's the upper end range of this drive since it's a 144 volt system. But anyways, it'll still work. So if I give her a little bit of throttle, see, she has issues, but she'll spin. So I can't regen because I'm using the capacitor again. I got to get my bidirectional buck boost converter done one of these days. But it'll spool down on its own here. So it looks like it works fine, right? We had a little jerkiness at the start, but what's actually going on is this drive has lost a phase. And if I put this in an area, I'm going to put that like right around here because I think that's where one of the phases on the motor is. And so if I give her some throttle, nope, give her too much. There we go. So I've probably got, so if I were to nudge it, it'll start spinning, but I've got it like right in between a phase on the motor, between one of the poles. And so it's firing two of the phases, and the third one can't get it over, and so it's just kind of gonna, if you look, it's moving back and forth just a little bit. So it's right on the hairy edge of actually trying to spin. But I'm doing that because I want to show you with the meter here. If I go ahead and zero it, my meter's not that great. Oh, I got a pretty good zero that time. So if I can get in here on one of the phases, you'll see we've got about roughly, it's kind of hard to tell. Can you see that? Let me take it out of auto range. So we're roughly, it's roughly about 50 amps. The problem is it's about 0.9 hertz, and when you're down at that slowest speed, AC doesn't work on here, so it's on DC. But you can see it peaks at 50 amps or so every once in a while. And so that phase has got 50 amps flowing through it. If we were to go and look at, say, this is the next phase, you see that one also has about plus or minus 50 amps flowing through it. You can see it peaks up to about 40 something every once in a while. And if we look at the last phase here, what we got? Zero. Yeah, pretty much zero. Zilch. So we've lost this outer phase, which happens to be this one over here. So another really interesting thing. So we've got about 50 amps of circulating current going through here. This phase has died, so we need to figure out if it's the power stage. Actually, I've got one floating over here. So here's one from a different drive. These are the outside edge here. There's 8 MOSFETs, and then the other side's got another 8 MOSFETs. And then the inside of it is, there's 8 diodes. The catch diodes, recirculating diodes are all on the inside. And you can tell this phase, there's a few chips that have exploded on it. And something similar may have happened to this phase. At one point, it could have died a horrible death. One sec here. Another thing that could have failed is at the bottom of each of those phases is the gate driver board. And this gate driver board has also met an untimely death. You can see the whole bottom of it got exploded, and it killed pretty much everything on the board. So it could be a gate driver that's failed for this phase. This is underneath here. That phase could be dead. Or if you look the microprocessor, it does its thing, and some I/O gets processed over here, and it comes back along here, and eventually makes it down these three cables. Those go to the 3 gate drivers that are down inside. And so we could have something wrong on this board, with the processor board, or with this board. So what we're going to do is I have a whole nother assembly of this. Actually a few screws and this whole thing will pop off, and I can put a whole nother set of known good electronics in it and do this exact same test. And you know what, that will probably be the next video. And if that works, then we know that the gate drivers are fine and the power stage is fine, and that we've got a problem on one of these boards, and then I can take those boards off individually and track down, is the problem on here, is the problem here, is the problem here. And we'll just narrow it down. Once we know which board it is, then we can go in and figure out, oh, has this chip died or has that chip died, you know, and so, they do die, they're socketed, so you can pop them out and plug in a new one. But we got to figure out what exactly is the problem first, where it's located. And so it's just basic swaptronics until we narrow it down. This poor thing's just pumping 50 amps through this motor. It's probably getting warm. Yeah, it's actually not too bad. But anyways, yeah, I hope this is somewhat educational for you. And yeah, it's a 3-phase motor. They can run off 2 phases. It's just not as efficient. And when you have 2 motors driving the same vehicle, they get a little, they can start fighting each other. So that's what causes the jerkiness. And just I'll give this guy a little kick, and she'll start up. So yeah, that's what's going on. This drive happens to have lost a phase, and we'll go ahead and see if we can't fix it. Anyways, thanks for watching.